Hello students, in this video we'll discuss how to compute the Wronskian of a collection of functions and how that relates to linear independence. The Wronskian of three functions f of x, g of x, and h of x is the determinant of the matrix given as follows. We write Wronskian of f, g, and h is the determinant of this matrix. F of x, g of x, and h of x go in the first row. F prime of x, g prime of x, and h prime of x go in the second row. F double prime of x, g double prime of x, and h double prime of x go in the third row. So we take our functions f, g, and h, put them in the first row, and every row underneath that has the derivatives of the previous row. If I was to do the Wronskian of just two functions f and g, so we can say similarly, the Wronskian of just two functions f and g will be the determinant of f of x, g of x, f prime of x, g prime of x. And if we had four functions, I would simply add the fourth function in another column and do one more row of derivatives. Now we make use of the following theorem. The functions f of x, g of x, and h of x are linearly independent if their Wronskian is non-zero somewhere. Let's see an example of this. Let's show that f of x, which is x, g of x, which is sine x, and h of x, which is cosine of x, are linearly independent. To do so, we'll compute their Wronskian. The Wronskian of f, g, and h will be the determinant of the matrix that we get by putting the functions in the first row. X, sine x, cosine x. Their derivatives in the second row. The derivative of x is 1, the derivative of sine is cosine, and the derivative of cosine is negative sine. Then we do the derivative of the second row and the third row. The derivative of 1 is 0, the derivative of cosine is negative sine, and the derivative of negative sine is negative cosine. Now, to compute the determinant, we recall what we did in Calc 3. We put a plus, minus, and plus along the first row, and we expand along minors. So to do so, we will have positive x times the determinant of the matrix that we get when we eliminate the row and column in which x resides. Doing so, I will have cosine of x, negative sine of x, negative sine of x, negative cosine of x. Then we proceed to sine, so I'll have a negative sine times the determinant of the matrix we get when we eliminate the row and column in which sine resides. If we do this, we'll have a 1 negative sine and then a 0 negative cosine. And finally, I'll have a positive cosine times the determinant of the matrix we get when we eliminate the row and column in which cosine resides. When we do so, I will have a 1, a cosine, and then a 0 and a negative sign. So, computing these 2 by 2 determinants, we see that this is going to be x times negative cosine squared, and then I have a negative, 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 so there'll be a negative sine squared x. Then I will have negative sine x, and then a negative cosine. And finally, I will have a positive cosine x, and then I'll have a negative sine. So these terms over here will be a positive sine cosine and negative sine cosine. Those terms will cancel. And negative cosine squared, negative sine squared is negative 1. So we see that the Wronskian of these 3 functions is equal to x, and x is not 0, and that implies that these functions are linearly independent. Thank you very much.